Okay class, after we learn the binomial distribution, we also have to learn the Poisson distribution. Later you will see the difference of them. Okay, so for the Poisson distribution formula, okay, you can see from the slides, so is e power of minus lambda. Okay, this one we call as lambda. So multiply with lambda power of x divided by x factorial. So x is the number of the events, lambda is the expected number, or we call as mean. So e, you know that there's exponent. So for the just now for the binomial, you will set it in this way, right? N and P. So when come to Poisson, it's x in Poisson distribution, and we need mean only, lambda. Okay, so for the Poisson distribution, we also have to learn to calculate mean, variance, and standard deviation. So this is the okay, sorry for the one just now. This is on the Poisson distribution to calculate the mean, variance, and standard deviation. So the formula will be slightly different with the binomial. Okay, so from here we can see that the mu is equal to mean. Okay, so our mean mu is equal to lambda. Alright, and also the variance standard deviation, their value will be same as the mean as well. Okay, this is the difference between the Poisson and binomial. Okay, so again, lambda is the expected number, or we can say that that's mean. Alright, so now let us look at the example. Okay, so based on the graph, okay, that actually is given a table, and then we come out with the graph. So for every x value, okay, like when x equal to 0 here, our Poisson, the probability will be, okay, the best way to understand will be in this way. So it means that when your x is equal to 0, so the probability is 0.6065. When your x equal to 1, the probability is 0.3033. So you have to know how to read through from the table. Okay, so let's say if the question asking you to find the probability of x equal to 2, so you just need to refer the table, and you will get 0.0758. Okay, so from your slides, actually there's like something, the method that was written in this way: x equal to 2, and then lambda is equal to 0.50, and you will get 0.0658, right? You also can follow this method, but normally I will using this method to understand, because I will shortcut it in this way. Poisson, the mean is 0.50. Then I will understand that I'm using the mean here, already started here. So I will just proceed to the calculation. Okay, so now if the case given is px less than 2 and asking you to find the probability, will be px equal to 0, we're starting with the 0, then plus px equal to 1. So since less than 2, the 2 cannot be included, so the probability is 0.6065 plus 0.3033, and you will get 0.9098. So this is the answer. If there's exactly this value, which means that you set the equal, then you just refer the value of that. But when there's less than, it will come out something with the summation. So it depends on the case. So now let us look at an example. So this is the example by given the mean is 2. So will be x Poisson mean is 2. Okay, So the question asking to find, okay, A is 0 bacteria means that it's X exactly 0. So the formula, what is the formula just now? It's Px equal to X is e power of minus lambda, then minus power of x factorial. So it will be e power of 0. So then 0 power of x. So x is, what is the total? Sorry, I substitute wrongly. Is e power of minus 2 because it's minus lambda. So then 2 power of x now is 0. So 0 factorial divided by. Okay, so you will get 0.1353. This is the probability for part A. Part B, at least 1 means that P more than equal to 1. So we can 1 minus Px equal to 0, right? Because more than equal to 1 will be 1, 2, 3, and so on, and we included, right? So why not we just use the overall, which is equal to 1 minus the 1 we don't want, the probability, which is x equal to 0. So just now x equal to 0, we get the answer already. So we just need to substitute. And our final answer is 0.8647. Okay? And the C is calculate the expected value. So our expected value will be Ex, or you want to make it mean, okay, lambda or mean like this way, will be equal to 2. Okay, because just now already given from the question, the mean number, mean will be same as the expected value. Okay, now, so when do we need to use the binomial and when do we need to use the Poisson? Sometimes the question will come out a keyword like binomial. Okay, solve the question by using the binomial distribution. Maybe another one is solve the question by using Poisson distribution. So when the question not given the instruction, so what we have to do? So we have to check. Okay, you can check based on this. The MP less than and equal to 20, then we have to use the. So if the MP is less than equal to 20, we have to use the Poisson. Okay, so how to check using this? When n more than 20, then p less than 0.05, or n more than equal to 50 and p less than equal to 0.1. So you have to check by using the multiplication, n times p. So if we get less than equal to 20, then we just proceed by using the Poisson distribution. So now we have to know that when n is large, p is small, the Poisson distribution can be used to approximate the binomial. So you can check by MP less than 20, then we just use Poisson. Okay, and when larger n, smaller p, the better approximation. So the events on the interest lower, but we have the highest value of n, so we will have the better approximation. So now, okay, this is a formula for the binomial to get the mean, or we say the expected value. So what's meant by Q? Okay, actually Q is equal to 1 minus P. Okay, it's the same thing. Just now what we find is like just 1 minus P, then what do we get? So Q is equal to 1 minus P. So when n approaching infinity, when means that we have large n. So P approaching 0 means that your P is small. Okay, so your Q is equal to 1 minus P. Okay, and it will be equal to 1 approaching, because when P here is very small, we imagine that there's 0.0000000 something. So 1 minus 0.00000 something, because it's very small, we still assume that there's 1. That's why we will get Q is equal to 1 minus P when n approaching infinity, means that n will have a very large value and the P is very small only. Alright? So let us look at the example. So now, given 0.1% from the certain population are born albinous, if 2,500, so obviously P is what? 0.001. Alright? And then our n is 2500. So now, we don't know which distribution we have to use, right? Either binomial or distribution. So we check by using MP. So it's 0.001 times 2,500. What do we get? We will get 2.5. Am I right? So this one is less than or equal to 20. So means that we have to use the Poisson distribution. We need lambda. Lambda means that what? Lambda is equal to mean, is equal to MP. So for this question, our lambda is 2.5. Now, we solve the question since we have the information. There's only one person, so it means that x is totally exactly equal to 1. So it will be e power of negative 2.5. So 2.5 power of 1 divided by 1 factorial. And at the end we get 0.2052. Alright? So B is P less than 2%, which means that is Px equal to 0 plus Px equal to 1. Since there's no equal sign for the 2, so the 2 is not included. Okay? So it will be e power of negative 2.5 power of 0 divided by 0 factorial plus exponent negative 2.5 times 2.5 times power of 1 divided by 1 factorial. So our answer, you can list out each part of the calculation, the answer here, okay, step by step, and you will get 0.2873. Okay, so this is our final answer. Okay, for the same example, let's say we still want to use the binomial distribution method. Okay, now we can check it. So just now our P is 0.001, our N is 2,500. So in binomial distribution, it will be 0.001. Your P is 2,000. Sorry. No need to state equal sign actually. So it will be N is 2,500, P is 0.001. Okay, so the formula is NCX PX 1 minus Q. Oh no, sorry, it's 1 minus P power of N minus X. So the A is exactly 1. So we 2500C1 1 power of X. So here will be 0.999. So it's 2500 minus 1. And you will get the answer same as just now. Okay, so for Px less than 2 is equal to Px equal to 0 plus Px equal to 1. So it's 2500C0 1 power of 0 0.999 2500 minus 0, okay, plus the 2500C1, okay, power of 1. So this one minus 1. At the end you will get 0.999 0.0821 plus 0.2052, and our final answer will be same as the previous one. So for this case, if you're using binomial, you can see that the n is so big already. So when you list out one by one, you see everything is like very big value, or else will be very small like this. So we'll be using Poisson method. Okay, that's the difference of it. Alright.